What's up, people? I'm back. Alright, so today we're going to be talking about linear equations. So if you got your graph paper, this might be a good place to be doing your notes, because we're going to be doing a little work on the table, and then we're going to be graphing it to see what it looks like. So I'm going to be doing the notes today on the graph paper. So if you got yours, you might want to go get it out, okay? So we'll play some more of that 80s classic here in a minute. Alright, so we're going to have a table that I'm going to do over here on this side, and I'm going to do the graph over here. So if I were you, I'd kind of split my paper in half. So we're going to do the table here, graph here, okay? Table, graph. Now all these should be linear, okay? So when you make them, they should make some type of straight line. They should not be crooked. They shouldn't look like a heart monitor. Okay, so this first one we're going to do is going to be real simple. We're going to do y equals 3x plus 4, okay? So you can see this is in our y equals mx plus b format, okay? So remember, this is our slope intercept form, y equals mx plus b. We're going to continue to talk about that. As we've talked about before, the m is the slope, so you can see here that the slope of this line is going to be 3. So it should be a positive 3, but we're going to make us a little table over here. We're going to pick us some x values. We'll put the 3x plus 4 here, and that's what we're looking for in the middle. And then we're going to get out a y value, okay? Now for the x values, you could pick any number under the sun you wanted to pick to put in there for x. But remember, we're trying to graph it over here in this little bitty section. So you could put 20 in there and do 3 times 20 is 60. 60 plus 4 is 64. But I don't think we got room over there to do that, okay? So all the numbers I'm going to use here are close to 0, okay? So I'm using numbers close to 0. The numbers I use close to 0 because that keeps the graph small, okay? So you want to keep the graph small so I can actually fit it on here so we see what we're doing. Alright, so here's the ones I'm going to use. I'm going to use 2, 1, 0, -1, and -2. Now you could use other numbers if you want to, but those are the numbers that are closest to 0, so that's what I'm going to use. So in this first one, the first x number, okay, these are my x numbers. First x number I'm going to put in there is 2, so that is going to be 3 times 2 plus 4. Alright, so what's 3 times 2? 6, right? 6 plus 4 is 10. So in just a minute, my first point I'm going to graph is 2, 10. Again, the x number comes first, the y number comes second in the ordered pair. X, 4y, just like it is in the alphabet. If you don't know your alphabet, I can't help you with that. Okay, the next x number we're going to use and put in for x is 1. So that's 3 times 1 plus 4. What's 3 times 1? 3. 3 plus 4 is 7. So my next ordered pair I'm going to write down is 1, 7. The x number comes before the y number. 1, 7. Alright. 0. Putting 0 in there, right? 0 in for x. That's easy enough. 3 times 0 is 0. And 0 plus 4, of course, is 4. Okay? So in the next ordered pair I'm going to graph is 0, 4. 0, 4. Alright, the next one we're going to put in is -1, so this is going to help us review some of our integer rules. So what is 3 times -1 plus 4? So 3 times -1 is -3. -3 plus 4 is +1. Okay, so remember when they've got different signs, you just really subtract them and take the sign of the bigger number. So that would be a 1. So my ordered pair is going to be -1, +1. Again, the x comes before the y. -1, +1. And then my next x number I'm going to put in there is -2 for x. So I'll substitute it in there. 3 times -2. 3 times -2 is -6 plus 4. What's -6 plus 4? Well, again, they're different signs. So you subtract them, take the sign of the bigger number. So if you subtract them and take the sign of the bigger number, that would be -2. So my ordered pair is going to be -2, -2. Okay. So again, you can pick any numbers you want to pick. I'm picking numbers that are close to 0 because I want to keep my graph small. Okay. So close to 0 keeps graph small. So I'm suggesting you use these numbers. All right, now let's come over here and graph it. See what it looks like. All right, so I'm going to go there and there. So my first one is 2, 10. So I'll come over 2 on the X. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my first point. Okay, 2 10s up there. Got that one. Check. Next one is 1, 7. So I'll come over 1 on the X. 1, 2, 3, 4, 5, 6, 7. There's 1, 7. Next one's 0, 4. So 0 means you don't go any way on the X. You just go up 1, 2, 3, 4. Got that one. Next one's negative 1, 1. So you come over negative on the X 1, and you go up 1 on the Y. And then the last one we are doing is negative 2, negative 2. So you go left 2, down 2. Hook all those together. Okay. If I had my ruler out, it'd be easier, but you can see it looks like that. Again, you can see that if you count that and go the rise over run, that's up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1, so forth and so on. So the slope is 3 over 1. And since we're going up and right, all that's positive stuff, you can see that here, that is a positive 3, so the M is 3 over 1, and this has a positive slope. Alright, so there's the graph of that. Easy enough, okay? So now we're going to do one that's got a little bit different look to it, okay? Let's slide this down some. Let's try number 2 real quick. This time let's say our equation is y equals negative 4x plus 2. Okay, y equals negative 4x plus 2. So we're going to set our same little table up here. We got the x column. We got our little column here where we're going to do our work. We're going to get the y results over here. In the middle, you just write that right there, negative 4x plus 2. Okay, so again, I'm going to use my same numbers. This time I'm going to go just a hair faster, just to speed it up just a little bit, but I'm going to use my same numbers. 2, 1, 0, negative 1, and negative 2. I'll spread it out a little bit this time because I might need a little more space to do some work. Okay, so I'm going to take the 2. My first x number again is, I'm going to use 2 in there. Again, I'm doing this to keep the graph small. So I'll put the 2 in there. That's negative 4 times 2 plus 2. So negative 4 times 2 is negative 8. And negative 8 plus 2, again, those are different signs. So you subtract them and take the sign of the bigger number. That will give you negative 6. So we're going to do 2, negative 6. All right, my next x number I'm putting in here is 1. I'm going to substitute it right there, so negative 4 times 1 plus 2. What's negative 4 times 1? That's negative 4. Now, if I do negative 4 plus 2, again, those are different signs. So you subtract them and take the sign of the bigger number, and that would give you negative 2. So my next point I'm going to graph is 1, negative 2. 0, that's the easy one, right? So we take and put the 0 in here. Negative 4 times 0, well, anything times 0, of course, 0. 0 plus 2 is 2. So my next ordered pair I'm going to graph is 0, 2. Alright, now we're going to put a negative number in here. So we're going to put negative 1 in for x. So that would be negative 4 times negative 1 plus 2. Let's see if you remember. What's a negative times a negative, folks? A negative times a negative is a positive. So that's 4 plus 2. Easy problem, right? 4 plus 2 is 6. And then I'm going to graph that, which would be negative 1, 6. And then my last one I'm going to put in there is negative 2. So negative 4 times negative 2 plus 2. So what's negative 4 times negative 2? Again, a negative times a negative is a positive. 4 times 2 is 8. And 8 plus 2 is 10. Hey, if you look there, you probably see a little pattern going, right? -6, -2, +2, 6, 10. You can see a little pattern working there. And let's see what it looks like when we graph it, okay? So let's come over here, put it on the graph. All right. So we go -2, which means you go left, and then, I'm sorry, got to scratch that. That's +2, 6, so it means you go to the right on the x-axis 2, and then down 1, 2, 3, 4, 5, 6. All right. That is 1, -2, so that means you go right 1 on the x, and then down 2 on the y. 0, 2, so if you're at 0, 2, that means on the 0 means you don't go any direction on the x, you just go up 2 on the y. And we got that there. Next one's -1, 6, so that means you go left on the x, -1, and 1, 2, 3, 4, 5, 6. And then the last one's -2, 10. So again, we start at the origin, you go over -2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that even on there where you can still see it? Yeah, you can still see that. Okay. And then of course we're going to hook all those little points together. It'll look something like that. Okay, so you can see how this one had a. You can see how this one
had a positive slope right here, going up and right. This one, of course, has got a negative slope because it's coming down and right. So this has got a negative slope. Again, if we go over here and look at our number right here, this number is the m. So right here, that would mean that would be -4 over 1. So if you're going -4 over 1, that means you'd go down 4 and right 1. Let's see if that works out. So down 4, 1, 2, 3, 4, and right 1. Down 4, 1, 2, 3, 4, and right 1. Down 4, 1, 2, 3, 4, and right 1. Okay, and you can see how all that works out. So we know the difference between the one that's got a positive slope. We know the one that's got the negative slope. We also know, of course, that that number in front of the x, that is the m, okay, right there. Same thing here. We got the m. So whatever number is in front of x, this is the important number. It's telling you the slope. When you graph them, they should be a straight line, okay? Either positive slope, negative slope. We'll talk about 0 and undefined a little bit more later, but that'll get you started for sure. All right, these are graphing linear equations. We're moving on up, people, moving on up. If you know the name of this song, you can send it to me. And last thing is here, I'll give you a little riddle here. So, what flower? Oh, better get my pen out. What flower can you find on your face? Well, there's a good question. What flower can you find on your face? If you know the answer to that riddle, of course you can email it to me, get a little extra credit. You can also tell me the name of this fine song, one of the 80s dance greats right here. She used to be a Laker cheerleader once upon a time, so if you're any Laker fans out there, you might could look that up and figure it out. All right, until next time, people, this is Mr. Reid, over and out. Sayonara, ciao, peace.